Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about the Election Day asteroid that will kill us all, or not, and of course, taking listener questions about all the amazing things in this universe. We record every Thursday at 8 p.m. Eastern, and you can follow along online or leave a voicemail by going to spaceradioshow.com. And in today's Blue Shift, I'll be talking about update your models. But first, the news. Hey, Space Cadets, welcome to Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute, and for the next half hour, your agent to the stars. Got an amazing show for you today where we talk about all the beautiful things in our universe. If it's above the Earth's atmosphere, it's in this show's world. It's right here. We're going to do it. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here at Spaceman Studios in New York City. And you can leave a voicemail at spaceradioshow.com to get your voice on the air, get your question on the air. You can also follow along with our Space Cadets tuning in live from around the world, including but not limited to Washington, D.C., Germany, Seattle, Washington, London, UK, Duluth, Minnesota, New Orleans, Austin, Texas, Hull, New Jersey, Halifax, England, and Leander, Texas, and more. We'll take questions that you send there to, and by we, I mean me. And seriously, folks, I've prepped less than 5 minutes of show material tops, so get those questions in. That's right, Space Cadets, you get to see all the nitty-gritty behind the scenes. Folks, if you're tuning in for the first time, this is a real radio show. So that's why everything's broken down by segments, everything's timed, everything's on the ball, and you know what? Sometimes even the microphones work. It's been a great month. I took a few weeks off. I hope you took a few weeks off. I hope everyone enjoyed their vacations, and now it's back to work and everything's broken. But I think... Thank you, Nancy. You're back online. Everyone's back online. We are building up a really good audience, and we're going to get back to it. We're going to get back to it. I believe in you. Just one of those days, folks. All right. What is this? Is everything going wrong today? Before I start taking calls, I wanted to share some interesting bits of news I caught recently. And how could I possibly ignore the hubbub over the Election Day asteroid? So it hit the news this week. And the short version, everyone's blown it totally out of proportion because, of course, they're saying, oh, there's an asteroid and it's coming on November 2nd, Monday, November 2nd, which is the day before the U.S. general election, which apparently a lot of people are paying attention to. And apparently Mother Nature's paying attention to and is sending in a third-party candidate in the form of a car-sized asteroid. Now... This asteroid is not a threat. What a ridiculous news story this is. Oh, random rocks fly by us all the time, and one is flying by us on November 2nd. Like, that matters. Now, here's where people go nuts, because there is like 0.5% chance that the asteroid will hit the Earth. We don't know. It's like we have a really hard time tracking asteroids, so we're not exactly sure where the asteroid is in space and how fast it's going, because it's the size of a car, and it's made of dirt, and so it's very dim. And also... the projected trajectory of an asteroid, that's right, projected trajectory of an asteroid is hard to predict because, like, even if it's like unevenly heated by the sun on one side, or it's a little bit lumpier, or if it passes by another asteroid, it can mess up its orbit. And so it's hard to pin down exactly where this thing is going to go. That's why there's only 0.5% chance that it will hit the Earth. We don't know for sure. What will happen if it hits the Earth? It's going to burn up in our atmosphere, folks, because a car-sized asteroid is tiny. Okay, the thing that killed the dinosaurs was a few miles across. A car-sized asteroid is peanuts. You need at least 10 times bigger asteroid to even make a boom, the thing's just going to obliterate in our atmosphere. It's dumb. What a dumb story. Why is this thing even existing? Yes, if you're listening to the radio broadcast, I've had microphone issues on my recording today, and so I'm a little worked up. It's just dumb. There's no story here. The reason we're starting to see more of these little asteroids, like these little asteroids have been buzzing by all the time and sometimes hitting our atmosphere all the time. But now we're seeing them because we have better telescopes like the Zwicky Transient Facility out in California, which has been in operation for a couple years. It's a great telescope. It's spotting a lot of these smaller asteroids that previously we just ignored because we couldn't see them. And now we can see them. And so it's like every 6 months, there's going to be an asteroid comes within 1,000 miles of the Earth. Then an asteroid comes. Yeah, because these are the small things that nobody cares about. We never cared about this asteroid before because it was never a threat. We never cared about asteroids like it, because the asteroids like it have never been a threat. But now because we built big giant telescopes that are doing other useful things, we happen to be capturing all these smaller asteroids. And so now we have the Election Day asteroid that is not going to hit the Earth. 99.5% chance it will not hit the Earth. And if it does, it will simply burn up in the atmosphere. Come on, people. And by people, I mean journalists. Really? This is what you decide to write about? This is what... Just fine, let's talk about something more fun. Where's my earpiece? Gonna listen to a question. It's gonna be fun. And we're all gonna have a good time. Right, Space Cadets? That's an order. Larry Beckham, even if it did hit, would it make it to the ground? No. No, it's just dumb. Stop calling it the Election Day asteroid. We're going to call it the dumb asteroid that nobody cares about. Yep. Okay. Someone's going to ask a question, and we're going to have a good time. Okay, so we've got a voicemail. Hey, Greg. Greg, are you paying attention? I didn't think so. Greg, can you please press the button? Just that. No, not that button. That's the one that turns off the micro. The other. Thank you.
Hi, my name is Nathan, and I am going into 4th grade. I like space and the solar system. I have a question for your space radio. Is Planet 9 real?
Wow, Nathan, going into the 4th grade, you love space and astronomy. I'm a big fan of you already, Nathan. Thank you so much for this question. I love the inflection in your voice as you ask, is Planet 9 real? Backstory. 1, some of you, maybe even me, contend that we already have 9 planets in our solar system. The 9th planet would be Pluto, which definitely does exist, whatever you call it. Leave that aside for a moment. You can feel free to ask that question, Nathan. We've got 8 planets, according to the International Astronomical Union. We've got 8 planets in our solar system. A couple groups, starting about 5-6 years ago, proposed that there might be another planet, a large planet, like something like Neptune size, beefy, out in the solar system. But if it exists, it has to be really far away. Because if it were close, we would have seen it by now. Because we're seeing car-sized asteroids. You'd think we'd find a Neptune hanging around in our backyard. It has to be really far away. We're talking like 50 to 100 times further than the orbit of Pluto. This is big. We have absolutely no direct evidence for the existence of Planet 9. What we have are the motions of some objects in the Kuiper Belt. The Kuiper Belt is a bunch of debris left over from the formation of the solar system. It's like the asteroid belt, but further away and also colder and larger. And some of the objects in the Kuiper Belt have some really weird orbits. And you could just say, well, maybe the orbits are just random chance. Like they're all aligned with each other, all lined up with each other. And you're like, okay, maybe these orbits are just the way because of random chance. If you assume you know everything about orbits and the likelihood of certain orbits to line up with each other, which isn't necessarily the case, but go ahead and make that assumption, then it's some like incredibly tiny chance that this is random. It seems like something is shepherding them along. And hence the proposed existence of a new planet, something to gravitationally shepherd these Kuiper Belt objects along and shape their orbits and tweak their orbits. Now, we don't have a picture of Planet 9. We don't know how big Planet 9 is. We have a guess. Some astronomers have a guess of where it might lie in the solar system. This is not the first time that astronomers have claimed to find evidence for a new planet. I mean, it's been a while, nearly 200 years since we found a new planet. That'd be nice to find a new planet in our solar system. Hasn't happened yet. We've been searching, astronomers have been searching for years now, like half a decade, and they've found diddly squat. I personally am pretty skeptical about the existence of Planet 9. I find the evidence for it, let's say, less than compelling. It's intriguing, it's interesting, but I feel there's I feel like there's a lot of observational bias going on in here. I feel there's a lot of selection. I feel like we don't understand the Kuiper Belt enough in order to make solid claims about other things past the Kuiper Belt based on the dynamics of the Kuiper Belt, because we're still learning about the Kuiper Belt. I'm perfectly willing to be wrong about this. If they came out tomorrow, like, here's our picture of Planet 9, I'm like, okay, I was skeptical based on thin evidence. Now this is pretty solid evidence because you literally have a picture of it. So, okay, Planet 9 it is. What are we going to name it? With the evidence that is currently in play, I am not going to bet very strongly on the existence of Planet 9. I do not believe Planet 9 exists right now, because I weight my beliefs in accordance with the evidence. There is not a lot of evidence for the existence of Planet 9, and so I don't need to believe in it until there is more evidence. So that's where I am. Is Planet 9 out there? I don't know. Right now I'm saying no, because there is no strong evidence for its existence. I could have my mind changed for me by future evidence. On the other hand, we've been working on this, trying to take a picture of it for like 5 years now and come up short. And the evidence that we have for it based on the orbits of objects in the Kuiper Belt, there are other potential explanations for those orbits. It could be that it's just bias and selection. We're only seeing what we want to see in those orbits, and we're ignoring all the other orbits that, might make this conclusion a little bit weaker. And so that's where I am. I'm just not a big fan of Planet 9, because I have a rule. Some of you may have encountered this rule. I believe this rule is quoted on my Wikipedia page, of all places, that when it comes to science news stories, if it's interesting, it's probably wrong. And Planet 9 is interesting, it's probably wrong. Thank you for that awesome question, Nathan. I hope I didn't burst your astronomical bubble there. I hope you're still a fan of astronomy. This is how it works. People come up with cool ideas. Sometimes they're right, sometimes they're wrong. I'm Paul Sutter, and this is Space Radio. This show is brought to you by you. Please go to Patreon. Patreon.com/PM Sutter. Do it right now. Type it in. Easy peasy. And then you donate a few bucks and keep the show going. How bad is that? And then Nathan will ask more questions. And we need Nathan to ask more questions. See you after the break. Wow. I know. Planet 9. Planet 9. I'm just going to keep sighing and saying Planet 9. Get those questions in. Got another segment to go here. I'm having a good time by now. I want Nathan to ask more questions. That was pretty awesome. That was a good question, too. And some of you leave voicemails that are like 5 minutes long, and of course, I'm not going to play those on the air. There is instructions, like it says, please keep your questions shorter than 30 seconds. Of course, some of you ignore it. That's fine to go a little bit longer, but Nathan did it right. All right, you space cadets, you curious bunch. Look at you. Look at you. Okay. Okay. I'll answer your questions. That's what I'm here for. What mood am I in tonight? Wow. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more questions ready to go from the lovely and always curious Space Cadets. But remember, you can join the conversation by leaving an online voicemail or by following the live streams. Check out spaceradioshow.com for all the links. Now, I've got a big list of questions here. Am I going to make it through all of them? Who knows? Let's find out. We're going to start with Campbell Duncan on Twitch asking, what programming languages have you learned and what's your preferred language? It's interesting that you're going to ask about programming languages to an astrophysicist. I have something to say to all the aspiring scientists out there. If you are young, if you're interested in a career in science, you can get a bachelor's, you'll get a Ph.D., you go into research, blah, 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 all the usual. Surprise, surprise, you're actually going to be a computer programmer. And it doesn't matter what field of science. It doesn't matter if you're an experiment or a theory or observation. Just you are going to become a computer programmer. All of modern science rests in some form on computer programming, either for analysis or data collection or solving, all the usual. I have a particular fondness / geekiness for computers, and I actually, in my main research, especially early research, did a lot of computational science where I was building big simulations of galaxy clusters and black holes and jets and all sorts of cool stuff. So I have learned several languages like Fortran and C and Python and shell scripting and this and that and all that, like just all the languages. Nowadays, or more recent work, I've cooled off the heavy simulation stuff. Once I got into my postdoctoral appointments, I started still very computational, but not like the big giant, the 100,000 core simulations. It was more small scale stuff, and for that is almost exclusively Python with some C dug in there. Still use Python today. It's a great language. It is my favorite language. And really Python is pretty much the language du jour, especially for astronomy and physics. If you see some results in astronomy or physics, there's a good chance that was developed with the Python language. Previous generation, like in a lot still today, there's some older codes out there, things like IDL, Interactive Data Language, which is a horrible beast of a language. And I wish I never knew it. That's how bad the language is. But now it's all Python, are moving towards all Python all the time. Edward Hinton on YouTube is asking, if black dwarfs are a thing, how do they go supernova when they are totally dead? So this is a news story that popped up. I actually wrote an article about this over on space.com, looking into the far future of our universe in something called a black dwarf supernova. You can take a white dwarf, which is a ball of carbon and oxygen. It's a leftover core from a star that's like our sun. So in a few billion years, our sun will turn into a white dwarf. Then you let it cool off for like 100 trillion years, and then it's not very white anymore. It's cooled off, so we call it a black dwarf. And you might think that black dwarf can just hang out forever, just sitting around being a lump of carbon and oxygen. But there are some nuclear processes that can happen in the core of the white dwarf. These are very slow, or in the core of the black dwarf. Very slow. Very random. Just basically two nuclei hanging out next to each other can just randomly decide one day to fuse. And so what this does is this kind of cores out the black dwarf. Slowly over time, the stability of the black dwarf is threatened until it reaches a certain critical threshold where there's not enough stuff inside of it, and it undergoes a sudden gravitational collapse and then explodes as a supernova. And it's speculated that these supernova explosions, which will take place in about 10 to 100 years, which is, well, let's just say it's not tomorrow. In 10 to 100 years, these supernova will go off, and they'll be the very last sources of light to ever appear in our universe. So that's fun. We've got another question of Paul Gilligan from on YouTube asking about black dwarfs too. Could black dwarfs steal material from companions and reignite? Yeah. So if you've got a black dwarf and all of a sudden you pile up a bunch of material on it, yeah, it can go nova, it can go supernova. This happens all the time in our present day universe. The thing is, once you're talking about things like 10 to 100 years, all the black dwarfs that could have stolen material from companions do so in like the first 10 to the 10 years. And then you've got 10 to the 90, like you've got 10 to 100 years left to go of just waiting around. So by the time you've got black dwarfs, this concept of stealing material from a companion is so far in the past. Infinite Monkey is asking, how does Ceres have an ocean without tidal friction? Is it nuclear decay? Yeah, so the dwarf planet Ceres, the largest object in the asteroid belt, it's speculated that it either has or had just underneath the surface, not either a liquid water ocean or a very slushy, icy ocean. We don't quite know if it's active today or it was just in the past or recent past, if it did cool off. But then you have to wonder whether it's liquid water or slushy water underneath the surface. How does Ceres get the heat to do that kind of thing? Because it's kind of far from the sun. It's not orbiting a gas giant that can squeeze it and get its insides all hot. We think it is indeed nuclear decay. I mean, the Earth has a lot of warmth from nuclear decay. When you see a volcano, the energy that powers that volcano comes from, a large part of it comes from the radioactive decay of elements in the Earth's core or in the mantle. The Earth was born with a lot of radioactive elements. They decay over the time, they release heat, and that keeps our insides nice and toasty. So it's not unreasonable if something big like the Earth can stay hot enough to make magma in the present day, maybe something like Ceres, which is a dwarf planet, can be big enough that it can generate some slushy water oceans underneath its crust. Uncle Bill Druin on Twitch is asking, naming convention question, how do you feel about the name Squeezars? If you're listening on the radio, I'm just hanging my head in my hands. We've got quasars, we've got blazars, we've got squeezars, just astronomers, I'm talking to you. Knock it off. All right? Enough with the silly names. You want people to take us seriously? Well, then stop looking at Election Day asteroids and stop saying squeezars. How do you expect to go into a room full of people wearing like suits and ties, and then you get up in your torn jeans and your stained t-shirt? Maybe projecting some stereotypes here, and get up and say, we have discovered squeezars. How are we supposed to be taken seriously as a scientific discipline? How? Answer me. And don't include the word squeezars in the answer. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. Man, ranty Paul. Well, that's what you get for Election Day asteroids and squeezars. Squeezars. Please. Ugh, we're 3 minutes away from cheese, folks. Let's make this good. Oh, boy. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, which is my opportunity to get a little bit closer to you. Now, I've been ranting a lot in this episode, which is great. In my spare time, of course, I'm recording this in the middle, tail end, beginning, wherever we are in the coronavirus COVID-19 pandemic. And what really gets me intellectually engaged is the modeling efforts, the projections. I feel like in March and April, when this was really getting going, people were paying a lot of attention to the models, and some models were promoted by government agencies and touted as like correct and like, oh, this is how many people are going to die and who's going to get infected and how will it spread and all this. Okay, the modeling effort has continued, obviously, but there isn't a lot of public attention on it anymore. But I'm just very interested. I'm very interested in who got it right, who got it wrong, who had accurate models, who had inaccurate models, who was including too much bias and assumptions, who wasn't incorporating the data right. And so I'm very interested. I wouldn't say enjoy that. I feel like that's the wrong verb for this. I'm very fascinated by the modeling effort because that's I'm a modeler. I'm a scientist. I'm a physicist. I'm an astrophysicist. I make models. I make projections. I try to predict what's going to happen in the future. And that's what these epidemiologists and data scientists are doing. And the models change. And the models of today, of August 27th, when I'm recording this, 2020, are different than the models of March 27th, 2020. They've been updated, not just with new data, but they've changed their techniques and their methodology. Why? Because they're scientists. Because they're trying to portray and capture an accurate reflection of reality so that they can make reliable forecasts. And when your model makes an inaccurate prediction, like something happens or something changes and your model doesn't incorporate that change, like if your model doesn't include, say, the effectiveness of masks, and then mandates come down, people start wearing masks, and that changes the infection rate or that changes the death rate. Your model is not going to capture that because it hasn't included those effects. And so you need to update your model. I love this saying. I love the saying, all models are wrong, but some are useful. Every model out there published is wrong in some capacity, but some of them can still be used to guide decision making. So when you see predictions, when you see forecasts, the people behind the forecast, the people behind the models are serious people. They're good people. They're trying to do a good job in a rapidly changing, very complex environment. So kudos to them. Better them than me. I would not do a very good job of it. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Please visit patreon.com/PM Sutter to learn how you can keep this show going. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio 90.5 FM in Columbus for making this show possible. Catch the live stream every Thursday at 8 p.m. Eastern, and you can visit spaceradioshow.com for all the links. And of course, thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing and sometimes ranting about. End transmission. At the beginning of the show, I didn't know if we were going to make it, folks. Stick around. I do have cheese to make us all feel better. Because what could possibly do a better job at making you feel better than cheese? Wow, this is a good looking cheese. I'm very excited to share with you. Let me take the price sticker off because that feels a little bit tacky. Oh, do I do modeling? Yeah, not like Vogue modeling. Scientific, analytic, forecasting modeling. Thank you. What's our cheese? Check this out. This is Olympiana brand Graviera cheese. Look at that. Nice little slice of Graviera cheese. This is a hard cheese made with 100% grass-fed sheep's milk. So, sheep eat the grass, we milk the sheep, we turn it into cheese. We've done that, and then they let this age for 12 months. They're calling it a hard cheese. It is not incredibly hard, but it's okay. I'm going to read from the back. This is Graviera brand. This is imported from Greece. Graviera has a sweet, nutty flavor and can be eaten cold, fried, or grated on pasta, meat, and vegetable dishes. You can eat it. Our aged Graviera is made in the town of Alessano in the Mount Olympus range. I've been to Thessaloniki near Mount Olympus, only from the milk of sheep that feast on mountain grass, herbs, and flowers. Wow. Sounds like these sheep. Did I say goats earlier? It's sheep. Sounds like these sheep are eating better than I am. They're feasting on grass and herbs and flowers. Is that... If you've had Graviera cheese, give me a shout out. Do I believe in paranormal activity? No, it's paranormal. It's outside. It's not normal. I mean, stuff happens to people that we don't understand, but that's no big deal. That doesn't mean it's like ghosts and stuff. It just means we don't understand what's going on. Okay. Yeah, that's good. That's good. That's good. I'm excited. A little bit greasy. It's greasier than I thought it would be. You can see it has a very, very delicate, fine texture. And when you cut it thin, it's almost translucent. Definitely strong, sweet, nutty notes. Let's go, Graviera. Okay, so it's not bad. It's not bad. It's not bad. It's not the greatest. It's not my favorite cheese at all. The smell is fantastic. But there's this deep, almost, I want to say grassiness to it. It's like the sheep chewing on the grass. Like there's an essence of that. Like I'm chewing on some serious grass. Feasting on grass on the slopes of Mount Olympus. It's good. But then there's this little note in there that I'm not really finding appealing. Overall, I like it. Overall, I would devour this entire thing. I'd fry it up. I'd put it on, what am I supposed to put it on? I'd put it on meat. I'd put it on pasta. I'd put it on vegetables. But when it comes to the aged cheeses, sorry, Greece, I think the Italians do this one a little bit better. I'll see you next week.